For part 8 on question 4, we're actually going to plug in values. So we have p is equal to half and mu is equal to n over 2, right? So we want probability that s is greater than equal to 80, which is equal to probability that s is greater than equal to 1 plus 0.6 times 50, which is the mean, because p is half and n is 100, right? So here we know alpha is equal to 0.6, and we know that mu is equal to 50. And what is the expression we had before? We had e to the mu alpha divided by 1 plus alpha times mu times 1 plus alpha as the upper bound for probability that s is greater than equal to 80. Now plugging these values in, we get, we get a bound of 5.0031 times 10 to the negative 4, right? Which is equal to something like, I'm just going to write this down, even though I know you know this. It's approximately equal to this. And what do we get from Chebyshev's? If you remember, we got 0.0278. So this is around an order of 100 off, because you multiply this by 100 to get something on the order of this. So this is, as we can see, an approximated version of Chernov's bound actually gives us something which is 100 times better than Chebyshev's inequality. And if you look at note 19.b, there's another Chebyshev derivation, a Chernoff derivation in that, which does not use the approximation which we used. And that actually gives us Chernoff 19b, I'll call it. That gives us, plugging in the values into that equation, we get 4.258 times 10 to the negative 9, which is so much closer, so much closer to the actual value, which is around 5 point something times 10 to the negative 10. This is so much closer to the actual value. So, well, we know that the weak Chernoff is better than Chebyshev, but the strong Chernoff is much, much better than Chebyshev. And that's what the first part of the question is asking, or is wanting to let you see. So this is the first part. Now let's go to the second part of the question, which actually asks us to find find an expression such that Chernoff bound looks like c to the n, and Chebyshev's inequality looks like n to the something. And when you compare c to the n, where c is something less than 1, then c to the n decreases or falls much faster because it's an exponential as opposed to a polynomial decay. So that's what we want to show by working through this next part, and which we'll do in a second. So Chebyshev's inequality, Chernoff bound. Now, what do we have? I'm just going to take whatever we had in the expression over here and then write it in terms of n and p. So e to the mu alpha is equal to e to the p alpha times to the n divided by, let's take out another one here, 1 plus alpha times p times 1 plus alpha whole to the n. So basically what I did was mu is equal to np, right? So therefore, what do we have? We have in our expression above, this is equal to e to the p alpha divided by 1 plus alpha times p to the 1 plus alpha whole to the n, right? And so therefore, this is going to be our c. C is going to be equal to this expression here for our bound to be c to the n, right? Now let's look at Chebyshev. This is Chernoff. Let's look at Chebyshev. What does Chebyshev give us? Chebyshev. So we have probability of s greater than equal to 1 plus alpha times mu, right? Which is less than equal to probability of absolute value of s minus mu is greater than equal to alpha times mu, which is less than equal to np times 1 minus p divided by alpha np the whole squared, which is equal to 1 minus p, cancelling out 1p and 1n, which is 1 minus p divided by alpha squared times p whole to the 1 over n, right? So we wanted to slot it into an expression which is alpha gamma times n beta, right? So we have, this is gamma Oops, that's another alpha, right? And beta over here is -1. So the point of this question was to show that a decaying exponential, which is then Chernoff bound, is much, much stronger than just a polynomial decay. So you have an inverse of a polynomial, 1 over n. A decay is much, much slower than an exponential decay like the Chernoff. That's why Chernoff bound is a much, much stronger bound. That's it for part 8 of question 4.